Welcome to the next section. Hopefully you survived the intro to GitHub, as well as the new commands like git clone and git push that we covered, all very important stuff. In this section, we are continuing to talk about working with remote repositories, specifically GitHub repositories, but you could sub in GitHub for other services. They're just not that popular, as we've already discussed. Specifically, we're focusing on two commands, git fetch and git pull. They both have to do with getting changes down from a remote repository like a GitHub repo. So if we're working with collaborators and our repository changes, how do we get those changes down? We've seen the other half pushing up with git push. So there's only three topics really that are covered here. They're all connected, something called remote tracking branches, git fetch, and git pull. And I've marked them all in yellow because they are a bit, I don't want to say trickier, but meatier. So they're all yellow. They're all critical. If you want to work with remote repositories, you could use Git your entire life and never share your changes with anyone, at which point you wouldn't need GitHub, you wouldn't need to push or to pull or to fetch or anything like that. But if you plan on collaborating, critical. All right, so let's talk about these commands and get more practice working with GitHub. Here we go. So this section is focused on getting code down from GitHub to our machine. And this is really important when we're collaborating with others because those other people will be changing our repositories, making new commits, pushing those up. How do we get those down? So before we talk about the different commands, git fetch and git pull, we have to understand a little bit more about how cloning a repo works and how remotes work. So when we clone a repository, whatever the repository is, whether it's one I made or I'm cloning React or some really popular open source repository, what happens is that, we have at the very beginning, nothing on my machine. We have the GitHub repository. Let's just say it's 3 commits, 1 branch, the master branch. When I clone that, of course, git clone this URL, I end up with the 3 commits, all files from the repository. We have a Git repo, right? We didn't have one before, now we do. And I have the master branch. But there's actually 2 branch references here, and we've only talked about one. So there is the standard master branch reference, a regular old branch reference. And I should mention, this uses master, but whatever the default branch is, when we clone, that's what we end up with. So whether it's main or master or trunk or purple chicken, it doesn't matter. Whatever that GitHub repo has as its default branch, that's what we're going to start with when we clone. Okay, so in this diagram, it's master. We have our regular branch reference, and that acts like any other branch reference. If we add new commits, it will move. But then there's this other thing, origin/master. This is something called a remote tracking branch reference. It sounds complicated, but basically, it's just a pointer in the same way that this is a pointer. But this pointer does not move, or I don't move it myself. It's pointing back to the last known commit on the master branch from the origin remote. So in other words, wherever this is pointing. Just like any other branch reference, I like to visualize them as our repo as a big book with a bunch of bookmarks in there. So these 2 bookmarks will start at the same spot, but they might diverge as I do more work and make commits on the master branch locally. So to reiterate, this term remote tracking branch, think of it as the bookmark or a pointer that remembers at the last time you communicated with this remote repo, here is where the master branch or the main branch or the purple branch was pointing on that GitHub repo, on origin. So they follow this pattern, remote/branch name. So Git names them for us. As we talked about, origin is a very common remote name. So we've got origin master, but that might as well be origin eggplant or upstream. That's another common remote name that we'll talk about. And then logo design, that might be a branch. It could be any remote name / a branch. But just as the example, if we clone a repo, by default when we clone, the remote name will be set to origin. And whatever that default branch name, in this case master, will give us origin master. So we can actually view these remote tracking branches if we use git branch with -r. We can see that branch reference. So I'm going to show you that now. So I'll make a new repository. Once again, just to demonstrate this, I'll call this animals, and I'll make it public. I won't add any files, so I'll just have this animals repository. And I'm going to do something slightly different that we haven't seen before. I'm actually going to create a new file on GitHub, so that when I clone it, I get some information along with the initial state of my repo. I'll actually have some files. So I can make changes and make commits on GitHub. So my animals project, I'll have a file called pets.txt, and then in here, I'm just going to keep it really simple. I'll add some of my pets over the years. I've got Rusty and Blue. I've got a cat named Scout. She also goes by the name of Rocket. And I've got some chickens. Okay. So whatever I have in this file, I then need to make a commit, just like I would locally on my machine. I'll just leave it as the default here, create pets.txt. We make that commit. Great. And now we have a file in my repository, and we have one commit. And remember, in GitHub, or on GitHub, the default branch name is main. If I don't push up a branch first, if I don't rename it, we'll go with main. Okay, so I'm going to clone this now. I'll copy this URL like we've done before. And then I have a new empty folder. So you can see on my computer, I'm not in a repo. And I'm going to clone. So git clone that animals URL. So we now have this animals directory. And if I type git branch, we have one branch, main. But as we talked about, when I clone something, we automatically get this remote, right? Git remote -v, it's called origin. And then the one branch we have is called main. But Git sets up a remote tracking branch for this main branch on origin. It's this little reminder here, in this case origin master, but in our case origin main. But it's a remote tracking branch, a bookmark that holds the spot, the most recently known state of the master branch on origin, or in our case, of the main branch on origin. So right now, if I take a look, remember I can do this, git branch -r. I can see this origin/main, so the main branch on origin. That is the remote tracking branch. So currently, if we were to diagram this, we have two branch references pointing at the same commit because I just cloned. But in the next video, we'll see that we can get them to diverge, and we can check one out and see the differences. All right, so imagine we have this hypothetical repo with 3 commits that we cloned, and there's a master branch. And then, of course, we have this remote tracking branch we talked about that says this is the last known spot that we know of for origin/master, the master branch on the origin GitHub repo. Anyway, I do some more work. What happens? If I'm on the master branch, I make new commits. That master pointer updates, just like it always has when we've made branches and worked on branches and made new commits. That branch reference moves. It refers to the latest commit on that branch. So I might have 2 new commits. And you'll see the remote branch reference doesn't update, it doesn't move. That's the point. It stays at the last known spot for origin master. This is just master. Origin master is the master branch on origin, whatever that GitHub repo is. So let's demonstrate this. Let's make, on this animals project, right, I've got my main branch. And again, instead of master, it's main this time. On this main branch, I'll go ahead and make some changes. I'll make a new commit. So we've got this pets file. Here it is. I'll make a change or 2. Why don't I add my 2 childhood cats that are no longer with us? Let's see. We had Monty and Mocha. And then I'll add and commit. So git add pets, git commit -m, add childhood cats. All right. So now we have 2 commits just locally on the main branch. And if I type git status, we'll see something we haven't really looked at or talked about before. This right here. Your branch is ahead of origin/main by 1 commit. In other words, your main branch and origin main were pointing at the exact same thing, just like this, except master. But anyway, your main branch and origin main were pointing to the same commit, but then you made a new commit. And so now you are 1 commit ahead of where origin main left off. That's exactly what it's telling me. So if I do this again, I make another change. We had a tree frog as a kid named George the Frog. What was he? A red-eyed tree frog, I think is what they were called. Really cool looking, but not very friendly pets. Anyway, George the Frog, I'm going to add him. Git add pets, git commit, add George the Frog. All right, So now I type git status once again. Now we see your main branch, which is what I'm on, right? On branch main, is ahead of origin/main by 2 commits now. So in other words, we're at this point where there are now 2 commits that master has since the last known spot of origin master, or in our case, origin main. Anyway, they have diverged, and that's fine. That's totally normal, right? That's the point of this tracking reference, this remote tracking reference, is so that you know how far ahead you are, and it will update when we get new updates from the GitHub repo, right? We can change this. We can go ask to make sure, are there new commits? Am I missing stuff? And this might move somewhere. But anyway, we haven't gotten to that yet. That's where fetching and pulling come in. But what I want to show you is that if you wanted to, if you were ahead of origin master or origin main or whatever it is, like we are, we can still take a look at origin master or origin main. We can check it out. So imagine this is our scenario, and we wonder, what did this project look like when I first cloned this repository or when I last got an update from origin? If you want to know, you can check out origin master. So you will go into detached head, just like anytime we've done this before, checking out a commit. Don't panic, don't freak out. So let me show this. I'm going to go back here. We are ahead of origin main by 2 commits. This is what it looks like right now when we have these 2 new commits, right? These are new lines. I type git log, 3 total commits. So if I go back, git checkout, and remember, I can always see that remote tracking branch right there, origin main, git checkout, origin/main. Okay, we're in detached head. You can look around, blah, blah, blah. Here we are. This is what it looked like. This is that reference, that bookmark to origin main. From the last time we communicated with GitHub, this is what we had for the main branch. So I've moved ahead by 2 commits. If I wanted to work from here, just like any time that we've been in detached head, I could make a new branch and start working, or I can undo. I go back to main. If I just wanted, I'm done. I just wanted to poke around and see what it looked like. But this is just to show you really as an illustration of the fact that this is a reference to where we were, where the main branch was last time we communicated with GitHub. And now I can go back just to the actual main branch, git switch main. And this is where we are now, right, on my local machine. So now, of course, if I want these 2 commits that I have that aren't on GitHub, if I want them up on GitHub, it's as simple as pushing them, right? Git push origin master. Nope, origin main. Old habits die hard. There we go. Git push origin main. Refresh. And we see we now have our new commit here. Add George the Frog. I can take a look at pets.txt. Okay, so we have Monty, Mocha, and George the Frog. And if I look at all the commits on this repository, just go back. 3 total commits now. The original one, and then 2 that we just pushed. And now if I type git status, we're no longer 2 commits ahead. It says your branch is up to date with origin main. We just communicated with that GitHub repository, that remote repo called origin. And now our local repo knows what origin main looks like. It has a new version of that pointer, right? It's pointing at the same commit that main is pointing at. But if I make new commits on main, then of course they diverge. So I'll do that one more time. I'm not going to show you anything new. I'm just going to repeat the process. Let's see, another pet that I had as a kid. Oh, my trusty dog Wyatt passed away a couple of years ago. So we'll add him, git add dot, git commit -m, add Wyatt, rest in peace. Okay, I type git status, and now I'm ahead of origin main by 1 commit, right? So if I check out origin main, git checkout origin/main, we see Wyatt is gone. This is what the file looked like. This is what the repo looked like the last time we communicated with origin, which was just a couple seconds or maybe a minute ago when we pushed. So this is what it looked like. If I go back, which I can also do with git switch dash, we now see that we're ahead of origin main by 1 commit. So now I can push that up too, git push origin main. And when that finishes, we see we're now up to date with origin main. And if I refresh, we should see a 4th commit. There it is. All right, so I'll stop there. So now that we've talked about remote tracking branch references, quite a mouthful there, let's talk about working with remote branches. So for example, if we have a repo that we clone or that we want to work with that has multiple branches on GitHub, how do we work with those branches locally? Let me demonstrate what I'm referring to. I'm going to go to this repository I've made called Remote Branches Demo. You can find the link along with this video. I recommend you try this. So on the main branch, the default branch, we have two files, cactus with a nice cactus ASCII art and rose with rose ASCII art. But there are 4 total branches. And when I clone this repository, I'll copy that URL. I'll go to my local machine. We'll back out. Sure, into here, not a repo, git clone, and then this URL. All right, so we now have this remote branches demo. And if I type git status, I'm on the main branch. Okay, that's the default branch. As we've seen, if instead the default was master, that's the branch I end up with. Whatever the default branch is when I clone, that's what I get. So what about these other branches? Do I have them here? Git branch. No, I only have the main branch. So how do I work on, for example, the food branch where we have banana and popsicle? Or how do I work on the movies branch where we have Ghostbusters and Bambi? Well, it's actually not bad at all. I'll demonstrate it here. So in our example on these slides, we have a master branch that's the default and a puppies branch. Both of these are on GitHub. So when I clone that project, I get all the history, all the data, but that does not mean that it's all in my workspace at once. So as we saw, when I typed git branch, we only saw main, or in this example, master. I don't see all these other branches, right? Just main. So what exactly is going on? Well, if we look at the remote branches, remember the -r, it's a very different outcome. Git branch -r, and we see every one of those branches, origin/fantasy, origin/food, main, and movies. So my local repo, it knows about all of those branches, and it has a remote tracking reference where it can tell me where each one of those is. Remember, they're just like a bookmark that says, this is where fantasy is, this is food, this is main. So we know about them here. My repo knows them, but I don't see full-fledged branches for them. So how do I make that happen? Well, we need to talk a little bit about the relationship between a full-fledged branch and a remote tracking branch. By default, when we clone a repository, let's say in this diagram, it's a master branch that we end up with. That master branch is automatically tracking. It's connected to the remote branch origin/master, right? They're both master. They have the same name. So that's the default behavior. I didn't make that happen. Every time we've cloned something, in our case, it's main, right? On the main branch that we're currently on, we see this sort of message, up to date with origin/main. I did not make that connection myself. I didn't say, okay, Git, there's a main branch here and I want it to be connected to origin/main. That just happened. So we have these other branches that are remote, in our case, it's movies, origin/food, origin/fantasy. In this example, origin/puppies. So how do I make a branch here that is connected to origin/puppies? I want to work on that. So I could check out one of those branches. Check out origin/puppies or check out origin/whatever we have. Let's just take a look. Let's do origin/food. So I can do that. Check out origin/food. Well, I'm a liar. We can't do that. We need git checkout origin/food. And now we're in detached head, but you can see banana.txt and popsicle. And there they are in their glory. We've got banana and popsicle. So I'm able to check those out, but I'm in detached head. It's not the same thing as what we kind of talked about here. What I want is a branch that I can work on that is connected to origin/puppies. Rather than just checking out the remote branch, I want to actually have my own branch here that is connected to it. So the way we do this is actually super easy. Thanks to the new git switch command, we just switch to a branch with that exact same name. So if Git detects that we make a branch called puppies and there is already a remote branch called puppies, it's going to just assume that we want them connected. So we can change that, and we could have a branch called puppies that actually is tracking a branch called origin/cats. We can do that ourselves. but by default, we usually want them to be the same. When I do git switch puppies, Git will make me a local puppies branch, and it will automatically set it up to track the remote branch origin/puppies. So I end up with my own branch puppies, and it's pointing, or it's connected to origin/puppies in the same way that master is connected to origin master, or in the same way that main is connected to origin main. So if I go back to main, as we've seen before, right, automatically connected. If I now switch to one of these branches, one of these remote branches that I don't have, like movies. If I switch to movies, which again, we don't have that branch, and normally if I try and switch to a branch that doesn't exist here, we get this, invalid reference, right? I can't just do git switch plants. There is no branch called plants. But if I do git switch movies, take a look at that. I now have a branch called movies set up to track remote branch movies from origin, and it switched me over. So now I'm on the movies branch, and if I type git branch, we actually have movies and main. And if I take a look here, we've got Bambi, hello Bambi, so cute, and Ghostbusters. Type git status, and you'll see your branch is up to date with origin/movies. So we're now connected. This branch movies is referencing, it's tracking origin/movies. So the old way of doing this, just so you know, before git switch, it looked like this. It was slightly harder to remember and definitely clunkier. So git switch simplifies this a lot. If you want to work on a branch that is on a GitHub repo, you don't have it locally, you just use git switch and then the name of the branch. So super simple. Let's try one more example. So I can view all those remote branches, git branch -r. Let's go to the fantasy branch. I could check it out, right, and just go into detached head and take a look. Or I can make my own branch here that is tracking origin fantasy, and that's what I'm going to do. Git switch fantasy. Branch fantasy set up to track remote branch fantasy from origin. I'm on this branch fantasy now. I have 3 branches locally, and over here we see centaur and dragon. So let's make a change. I'm going to add a new file in here. How about on this fantasy branch, touch phoenix.txt. And I have a phoenix that I've copied from a free ASCII art website. Okay, so I'll add that. Git add phoenix, git commit, add phoenix.txt. All right, so what will I see when I type git status? Well, my fantasy branch is now ahead of origin/fantasy by 1 commit. Just like in the previous video, we had our main branch ahead of origin/main. So that means I have work on this machine. I have 1 commit on the fantasy branch that I can push up. So just like any other branch, git push, and then the remote origin, and then the branch we want to push. And if I want to push my new Phoenix commit, it's on the fantasy branch, so that's the branch I'll push up. And then if I head back to GitHub and I switch to our fantasy branch, we now have Phoenix showing up. All right, so what I wanted to show in this video is that if we use the git switch command and then a name of a branch that may not exist locally yet, but is a remote branch, if we use the correct matching name, Git will make us that branch locally and set it up automatically to track the remote branch with the same name. So that's really, really useful and very common. If somebody tells you, hey, I just pushed up a new branch called bug fix, or help me, Colt, I'm stuck. Well, I don't have that on my machine. I can easily get it by using git switch. Okay, so in the next video, we're now going to talk about a new command called fetch. So now we're going to start talking about fetching and pulling. So I'm going to start with a hypothetical. Here's some diagrams. Once again, we have a local repository, and then we have a corresponding GitHub repo. And currently, let's say I just clone down the local repo. I'm entirely up to date with whatever is on GitHub, right? I have the master branch pointer and origin master, both referring to this latest commit. But I go on to do some more work, and as we saw previously, they now have diverged. I have a commit that the GitHub repo, the origin repo, does not have. But I'm also working with some collaborators. And in the meantime, while I was working on this yellow commit, whatever that is, those collaborators, let's just say one person, Bobhead, added 3 new commits that you can see up there in green. So those are on GitHub. They're on the master branch. Let's say there's just one branch. So the master branch, they're on GitHub. I don't have them locally. I do have my new commit, but I don't have those new commits coming from Bobhead. So how do I get those changes? This is where the 2 commands we're going to discuss, fetching and pulling, or git fetch, git pull, this is where they come into play. So here's a diagram that I've put together. It's based on some really common diagrams that you'll see where we have different locations. They're not really physical locations, but we've got our working directory, our workspace, we've got the staging area, we've got our actual local Git repository. So something like git add, hopefully by now we know, will stage changes, right? Git add will stage a change, puts it in the staging area, and then git commit takes whatever is in the staging area and then creates a new commit in the actual .git folder, the real local repository. And then we saw that git push will take commits from a local repo and push them up to a remote repo like GitHub, or a GitHub repo rather. So git fetch and git pull down here both go the other direction. There are 2 commands that we can use to get changes, new commits, from a remote repository, from GitHub in our example. So we're going to start with git fetch. Fetching is going to take remote changes, so stuff coming from a GitHub repo, and bring them down to the local repository, not into our working directory. So that is what git pull does. I will illustrate the difference. It can seem a little confusing at first. Fetching allows us to download changes from a remote repo, but those changes are not integrated into our working files. So it's a way of kind of, fetching the latest changes and having access to them on your machine, but without having to merge them into our actual local working directory, without having to mess up our files. So think of it as this last paragraph. Please go and get the latest information from GitHub, but don't screw up what I'm currently working on. So we'll have access to it using this git fetch command. So we specify git fetch and then a remote. The default is origin, so you could just do git fetch. But if you do git fetch origin, it's going to fetch from the origin. If you have multiple remotes, which eventually we may, eventually in this course we will, it will fetch from whatever that remote is. Git will basically request origin and say, hey, origin, is there any changes on this GitHub repo? If so, I want them. We can also specifically just fetch one branch. So git fetch origin master or origin bug fix or whatever the branch is. So here's the same situation from before, right? We have this GitHub repo and a local repo. I'm working on it. I have a new commit in yellow. And then my friend, Bobhead, I think is what I said, added 3 commits to GitHub. He pushed them up. I don't have them. So if I don't want to screw up my local working directory, but I want access to those changes, I can fetch that branch, origin master, or I can just do git fetch and get everything from origin. And what will happen is that origin master, remember these remote branch references, that will update. So I have access, I can look at origin/master to see where is it, what's going on, what do the files look like, I can check it out, but my master branch has not changed in any way. That's exactly what this slide says. I got ahead of myself. I now have these changes on my machine, and if I want to see them, I can go check out origin/master, but my master branch is completely untouched. So basically, I've downloaded the changes, but I have not integrated them into my working directory, onto any branch that I'm working on. So if I lost internet, I would still have access to all of the work as of this moment in time that I fetched, right? I don't need the internet to go look at this stuff. It's on my computer. It's just not in my working directory. So that's why in this diagram, we've got fetch going from the remote repository, fetching changes down to our local repo, but not into the workspace. So in the next video, I'm going to demonstrate this, but for now, all that you should know, or the recap really, the main takeaway is that fetching allows us to get changes from some remote repo without actually integrating those changes into our working files. So we can go take a look, see what changed, what's new on origin or on any other remote, And we could specify if we only want to fetch one branch from a given remote. Otherwise, it's going to fetch all branches. So in the next video, I'm going to demonstrate this. All right, so I'd like to demonstrate using git fetch. And in order to do that, I need to have some changes on a GitHub repo that I don't have locally. Normally, this would come from collaborators, right, from other people I'm working with who are pushing their own changes up. But right now, if it's just me, I kind of need to fake that, or at least change the GitHub repo in another way. And I can do that. You can make any GitHub repo and manually add files and edit files. So that's what I'm going to do. I'm going to go on GitHub. So first of all, I'm working on this remote branches demo where I've got the ASCII art. So I've got the fantasy branch. We added that Phoenix into, and then I've got, three other branches. Let's go to the food branch. And I'm going to create a new file on GitHub. I won't have this on my machine, so I can create new file. And then I'm using this ASCII art website. I'm just going to take this apple and paste it in here. So if you're following along or doing something similar, you can edit any file on GitHub, assuming it's in a repo you own. And when you do that, as you can see here, it's going to generate a commit. And I also need to come up with a name for the file. So I'll do apple.txt, and then I'll create it on the food branch. I could create a new branch. I'm not going to do that. I'm adding this to the food branch. Okay, so now it shows just like any other commit. I have a new file, create apple.txt. It's showing up right here. I'm going to switch now to a different branch. How about to the movies branch? And I'll copy this Tinkerbell ASCII art and put that in a file on the movies branch called Tinkerbell. Tinkerbell.txt, and I'll paste that in, and I'll commit again to make a new file on the movies branch. So all of this that I've done so far, it has nothing to do with fetching. We're just updating the repo so that now we have stuff on GitHub that I don't have present on my local machine. And again, normally the way this would happen is that somebody pushes up changes from their own local repo, if I had collaborators. All right, so now we have 3 files on movies, and we have 3 files in food. Locally, let's start with the movies branch. If I go to the movies branch here, so just make sure I don't have any changes here, git switch to movies. All right, I just have 2 files, right? If I type git status, it says I'm up to date with origin/movies, but that just means I'm up to date with what my local repo knows origin/movies was, not what it exactly is at this one moment in time, because it can change. My repo is not constantly asking, hey, is there new stuff? Is there new stuff from GitHub? I have to do that. I have to tell it, go fetch changes, go fetch the latest. So that's what I want to do right now. I want to get the changes. Let's say my friend told me, what did I say his name was? Bob Head? Yeah, Bob Head told me, Colt, I just added to the movies branch. Go fetch the changes. You need them. So git fetch, and then I can specify origin to get all changes, or I can specify one branch, like movies. Normally, I just do git fetch origin, or just even git fetch, because it will default to origin. But if you only want to fetch one branch, then you can specify. So I'm going to do a git fetch, and I'll do origin just to be clearer. We only have one remote, but here we go. Git fetch origin. Okay, doesn't seem like a whole lot happened, right? Well, let's type git status now. Now I see a completely different message. It says your branch is behind origin/movies by 1 commit. So we can tell origin/movies that remote branch reference has been updated. It's the equivalent with different branch names of what we saw here, where we had master, origin/master was updated when we fetched to point to something new, but my branch itself is unchanged. So the same idea, but swap in movies. My movies branch is here, and origin/movies is pointing at a new commit. So if I go back, let's take a look at our files. Just 2 files in my working directory. I don't have that new work. If I type git log, not fur, git log, I don't see that new commit either. Nothing has changed in my working directory. However, origin/movies is now pointing to something new. It's pointing to a new commit, and I can take a look at that. I can do git checkout origin/movies. I just want to take a peek. What is the work that Bobhead did? And now I enter detached head. And now I see, oh, yeah, Tinkerbell is here, right? Ghostbusters is here, Bambi, but this is the new work. Okay, and if I type git log here, we see create Tinkerbell. That was the most recent commit because we are looking at origin/movies. So I could make a new branch from here if I wanted to, but what I'm actually going to show you next is how we can use the pull command to help us out if we actually want to integrate these changes into our working directory. But for now, fetch is just getting those changes from GitHub or any other remote repo, and it brings them down to my machine. It just doesn't integrate them. So I can switch branches too. Let's make sure I get back out of detached head. So let's switch back to movies. Okay, so I'm still behind origin movies by 1. Now let's switch to, what was it, foods? No, food. All right. And, oh, we didn't even have food on my machine at this point. I hadn't actually worked on it. So I just saw a message. I cleared it, unfortunately, but it said it set up the branch for me. And if I take a look at what we have, it's already up to date. It has that Apple file. So that's kind of a unique case because I hadn't even bothered looking at this branch yet, but because I switched to it for the very first time and I had just fetched, it used the most recent information that it fetched. From, remember, we have these remote tracking branches. Remember, git branch -r, it used origin/food. So I'm going to make one more change. Let's do another food. So we'll go back to food here, and I'll add a new file. And I guess I'll take this, is it tea, coffee, whatever this is. We'll put that, we'll call this, coffee.txt. So I'm making a new file on the food branch. I'll commit. Okay, and now I'm going to go back here, and if I type git status on the food branch, it thinks it's up to date. It is up to date with what we have, origin/food. But I can get more recent information, more up-to-date information. This time I'll just show fetching a particular branch. It will work exactly the same way. Git fetch origin food. And what we see now is a decent chunk of output. And if I type git status, it tells me, hey, you're on this branch called food, and it's behind origin/food by 1 commit. Just a moment ago before I fetched, it was up to date. Now it says you're behind by 1. So it tells me use git pull to update your branch. That's a sneak peek at what we're going to cover next. But as you just saw, git fetch got me the latest information from that food branch, and now we can take a look at it. So if I inspect, right, we're not looking at the latest version. We're not looking at what we just fetched. This is my working directory. But now, if I check it out, origin/food, detached head, and we see coffee is here. All right, so that's the basic idea of fetching. There are other things, that you would use fetch for. It's not just about updating the particular branch that you're on and getting the latest. Also, it might be that a new branch was created. That's really common. I can make a new branch here just as a demonstration. I'll delete it, but I can make one called, how about more food? Okay, create that branch. I'm doing it on GitHub. So I just made this branch. It's only on GitHub. I don't know about it here. If I do git branch -r, I don't see more food. But as soon as I fetch, git fetch, now it says, oh, there's this thing, origin more food. We know about it now. So if I do git branch -r again, now I have more food. It's exactly the same as my food branch. I didn't change it in any way, so we wouldn't see a difference. But now my computer, my local repo, knows about it. A moment ago, it didn't know about it until I fetched. So using fetch gets you the latest information about some remote repository. It just doesn't automatically integrate those changes into whatever you're working on. Next up, we're going to talk about git pull. So the git pull command is similar to fetch in that we use it to retrieve changes from some remote repo. But the big difference is that pull will actually update our head branch. it updates our working directory. Whatever changes are retrieved or pulled down from GitHub or some other remote repo will be integrated into our local repo and our working directory. So think of it as, okay, Git, go and download the latest commits from GitHub and immediately update my working directory with those changes. You can kind of think of it as a Git fetch plus a Git merge. So fetch in the sense that we are updating the remote tracking branch with the latest changes from some remote. So go and get the latest changes from, origin master or origin main or origin food. But then second step is take those changes from the remote tracking branch and merge them in or update my current branch that I'm on with those new changes. So the syntax looks like this: git pull, and then a remote name and a branch name. What really is important to understand is that where we run git pull from matters. So whatever branch I'm on, that is where the changes will be merged into, where I'm pulling down to. So for example, if I am on the master branch and I run git pull origin master, it's going to fetch the changes from origin master and then merge them into my current branch, which if I'm on master, then it's master. So it fetches and then merges, and just like any other merge, that can sometimes result in merge conflicts. So we need to resolve those just like a normal merge. So I'll demonstrate that, but why don't we start with something that won't result in a merge conflict. All right, so let's use our movies branch. I think I'm already on it. We have this movies branch. I did fetch in the previous video the most recent changes, right? We have Tinkerbell, but it's not on our actual branch. We just have it on the remote branch. So we have origin/movies, but I don't have Tinkerbell here in my working directory on the movies branch. So if I want to get those changes from the movies branch, I can do git pull origin, and then the name of the branch I'm pulling, movies, and I want to pull down to the branch I'm on, which is movies. So if you go to GitHub, or this is going to be hard for you to do unless you're editing the repo yourself, and I'll have an exercise so you get practice with this. On the movies branch, we have Tinkerbell here. I don't have that commit here. So I'm going to pull, and you can see it updates. If I type git log, I have a new commit here. So now my movies branch and origin movies, they're pointing to the exact same commit, right? And if I type ls, we see Tinkerbell right there. And over here, I see that file. So I pulled that down and it was merged into this directory. So I'll do one more demo. I'll update the fantasy branch. I'll add another file, just like this. It's a Cyclops. I'll call it cyclops.txt. Again, this is on the fantasy branch. We're simulating somebody pushing up changes, some collaborator. So now we have that Cyclops file. I don't have it locally. I'm on the movies branch, but I'm going to switch to, what did we call it? Is it fantasy? So if I want to get the Cyclops file, all I need to do is git pull and then origin fantasy. Okay, let's take a look. You can see it says create mode Cyclops. That means it created me Cyclops file. We see it here, and over here, we have access to it. All right, so that's really the core mechanic of pulling. What I'm going to show you in the next video is that merge conflicts can arise and often do if you're working on something that somebody else also pushed some changes to. So that's coming up next. So as I've said a couple times, pulls can result in conflicts. It's not a horrible thing, just like any merge conflict, we can resolve them. But sometimes you might have some work locally that is not on GitHub, and GitHub might have some commits that you don't have locally. So when you pull down, there may be conflicts. For example, if we're working on the master branch, I've made this new change, a new commit in yellow, and at the same time, my collaborator, Bobhead, made 3 green commits and pushed them up to GitHub. When I try and pull down, right, I pull those new commits down, git pull origin master, just like when we're merging, sometimes we get a fast forward merge and things go pretty smoothly. Sometimes Git can figure out how to merge things automatically, but sometimes there might be conflicts if we're changing the same files, if there's, conflicting changes. So when that happens, if there are conflicts, then Git is going to ask us to resolve them and figure it out and commit the changes. So I'll demonstrate that. I've set up, well, I have the food branch, right? On this food branch, I have this coffee file that I added. We'll say that my friend added it and pushed it up to GitHub. I don't have it locally. If I switch to food, I don't have coffee, right? I have apple, banana, and popsicle. And let's say that I decided, I really want to make a coffee file in here. So I'm going to make my own coffee, touchcoffee.txt. And then I'm going to open it up and put some coffee ASCII art, something different than what I have on GitHub. All right, so I paste this in, just another ASCII art coffee, and I'm going to add and commit that. Git add coffee, git commit -m, add my coffee art. All right, so now what I want to do is share that change that I've made and get it up on GitHub. But as a good practice, before you ever push something up to GitHub, you want to pull down and see if there's changes, right? If there's anything that is going to be problematic, any conflicts. So that's what I'm going to do. Git pull origin, and I want the latest changes from the food branch. But remember, I have a commit on here that does not exist on GitHub, and GitHub has a commit on the food branch that does not exist on my machine. So when I do that, oh no! Who could have ever predicted this? Conflict in coffee.txt. Automatic merge failed. It doesn't know what to keep, fix the conflicts, and then commit the results. So this is what came from GitHub that our collaborator, whoever that was, Bob had added. And then this is what I had locally. So do I want one? Do I want both? Let's do both. Why not? So I'll keep that. Remember, I can also use the VS Code, just accept both changes button. That makes it easy. I'll save. So I've got that. Now go back here. I need to make sure that I add the changes. So git add coffee, git commit, and we'll just do something boring like fix merge conflicts. Okay. And now we've merged together everything, but we see something that we didn't see before. Your branch is now ahead of origin/food. How is it ahead? Well, the reason it's ahead is that we have this commit and the merge commit, and those don't exist on GitHub, right? This is why we want to pull down first, merge anything if there are problems, and now I can push up to GitHub, and there won't be conflicts unless somebody happened to change GitHub, add new commits or something in the meantime, the last 30 seconds or so. Otherwise, we'll be good to go. So origin/food is still right here. This is what GitHub looks like at this point in time. It has the original coffee.txt file on this food branch, but it doesn't have my coffee commit, and it doesn't have the merge commit. So all I need to do now is git push, and then I can specify origin food. And now if I head over here and refresh, we see that we have a new commit showing up, fix merge conflicts. And if I go into coffee.txt, both of them are here. If we take a look at all the commits on this branch, you can see we've got create the apple. Okay, create coffee.txt. That was the one we did on GitHub. Then add my coffee art. That's the one that I just did locally. And then fix merge conflicts. So that's a simple example of generating a merge conflict when you pull. Some work happened that we didn't have. And at the same time, we did local work that conflicted with the work that was done and pushed up to GitHub. So when I pull down, there's a merge, and sometimes merges result in conflicts. All right, so that is the basics of using git pull. The last thing I'll show you with pull is a shorter syntax. That's the next video. Often when we're using git pull, we can get away with an even shorter syntax where we don't need to specify the remote or the branch we want to pull. Because it's really common to be on some branch, right? I'm on the food branch, and if I want the latest from origin food, that's where I would want to get changes from. Normally, I'm not going to pull some other branch onto the food branch. I want the latest from food on GitHub. So I could do git pull origin food. I'm on the food branch. I want food changes coming from origin. We only have one remote right now, so it should be origin anyway, right? We haven't configured another remote. But origin is just such a common name in Git. Again, you can change all of these, but it's so common that it will default. Git pull will default to origin if you don't specify a remote. And the branch will automatically default to whatever tracking connection is configured for your current branch. And as in every example we've done so far, the tracking connections are set up for us. We never specify a tracking connection. I didn't create them. Simply by switching to a remote branch. If you recall, if I go way back here, when we did a git switch, almost there. Okay, when we did this, right, git switch puppies or git switch food or git switch movies, that branch was set up for us and it automatically had a tracking reference to the remote branch. So typically these are just the same name. Puppies, origin puppies. Food, origin food. Main, origin main. You absolutely can configure them differently. I could have my food branch, my local food branch, for whatever reason, track the movies branch on origin. You just normally wouldn't want that. You normally don't do that. So git pull depends on the context of where you are. If I'm on the master branch and I run git pull, Git will automatically default to origin as the remote and master because I'm on the master branch and currently the tracking branch, the default value is origin master. So same thing with puppies. If I'm on the puppies branch and I run git pull, it's just a way of saying, please get the latest changes and pull them down, merge them into this branch from the remote version, from the origin version of puppies. So it's really common to do this because that's normally where you want to pull changes from, right? If I'm on the food branch, I want origin food. So let's do it. I updated the food branch in between videos just to make it faster. I didn't want you to have to watch. I added a T file. All right, I don't have that locally. I'll just prove it, right? We don't see T. We have coffee, but no T. If I do git pull, it pulled the food branch from origin. I see the T file right there. I can view it. If I do git log, I have that new commit. One more example. I updated the fantasy branch. I added a new file, Griffin. There it is. I don't have that. If I switch to fantasy, git switch fantasy. Okay, I don't have that new Griffin file. You can see over here, it doesn't show up. I could do git pull origin fantasy or just rely on the default git pull. And now I have it. It shows up there, and here it is. So if you want, you can use that syntax of typing out origin and typing the branch name. Sometimes you need to use that syntax. For example, if you have multiple remotes, which we will, we'll have an upstream and an origin. So sometimes we don't want to default to that origin. But for now, really, most of the time, you can just use git pull, assuming you want to update the puppies branch with the changes from origin puppies, or the movies branch with the changes from origin movies. All right, so that about wraps up fetching and pulling. Hopefully this diagram makes more sense now. When we fetch, we're getting changes from a remote repo, but they're not integrated into our workspace. When we pull, we get those changes from the remote repo, and then they are merged into our current head branch. Where we pull from matters. And that brings me to the last slide. Fetch gets changes from a remote branch or branches, updates the remote tracking branches with the changes, does not merge anything into your current head branch, and it's safe to do it anytime. It's not going to screw up any work that you're doing. Git pull, on the other hand, also gets changes from remote branches, but it updates the current branch with the new changes, merging them in. And it can result in merge conflicts. It is not safe to do it anytime, meaning that you can have conflicts. You can have changes integrated into your working directory, conflicting with work that you had been working on. So not recommended to do if you have uncommitted work. All right, so that's fetch and pull.